Our speaker this evening has over 25 years of experience at both Ingres and Actian Engineering. Please welcome the SVP of Engineering at Actian, Emma McGrattan.
Well, thank you. It's very fun for me to be performing in a dance studio. I tried to learn to dance in the 80s, and I went to a dance school, and they played some music, and they're like, just bounce to the music. And they said to me, we were never going to be able to teach you how to dance. So they gave me all my money back instead of trying to sell me more lessons. So anyway, that's me and dance. So what I'm going to talk to you guys about tonight is cloud data warehousing. As you know, there's a prize for whoever card we pull out at the end of the event. This is actually a programmable display. So it's even cooler than being a spherical robot. You can actually program the display in real time to say whatever it is that you want it to say. You probably haven't heard of Actian. Has anyone in the room heard of Actian apart from our own employees? No. We're one of those companies that do data infrastructure that few people have heard of. Our company has been around for a number of years. We, at one point, spun out of Computer Associates, actually in 2005. And since then, we've been on a bit of a buying spree. So we have data integration technologies, data management technologies, and analytics technologies. And what I'm going to talk about today are analytic technologies. We have an office on Long Island where we do some of the Avalanche development work. And we have about 300 employees worldwide. A little bit of a history on the technology I'm going to talk about, Actian Avalanche. We actually started life with this project back in 2010. We launched a technology called Actian Vector. Vector is an analytics database. It was designed to be the fastest thing in the market. It uses vectorization, which essentially is a really fast and cool way of dealing with large volumes of data. Instead of dealing with records at a time, you deal with arrays of data values at a time, and that's what the term vector comes from. It's essentially an array of data. In 2014, we launched a version of Vector in Hadoop, and at the time, Hadoop was really sexy and cool. All of the sexy and cool has pretty much gone out of Hadoop, right? People refer to data lakes now. You very rarely hear mention of Hadoop itself. So we decided that since everybody was moving to the cloud, we would too. So in March of this year, 2 days after St. Patrick's Day, which nearly killed me, we launched Actian Avalanche, our cloud data warehousing solution. It's built on the same technology as our Vector product, but it's re-platformed for cloud. So if you're familiar with cloud, you're aware of the fact that the I/O is completely different, communication between nodes is different, and so on. We're taking a cloud-agnostic approach. We've delivered for AWS today, because that was the easiest platform to develop on. In June, we'll have an early adopter program for Microsoft Azure, and by the end of the year, we'll be on Google Cloud Platform. The same technology that runs in our Actian Avalanche cloud solution also runs on-premise as the Vector product. So if you wanted to have a footprint on-premise, so maybe you're in financial services and there's some regulatory requirements that mean that your data's got to stay on-premise, you can run the Vector product on-premise, or you can have us deploy that as a managed service for you. So if you don't want to have database administrators, you don't want to have the nightmare of managing a very complex data warehousing environment, we can actually manage that for you. So the on-premise managed service is Avalanche on-premise, and as AWS builds out their on-premise solutions, our plan is to work with them. They announced that earlier this year. It seems like it's not quite ready yet, but as soon as AWS is ready, we're ready to move with them. This is a little slow. So talking about data warehousing, right? So you'll have seen in the title, if you paid any attention to it, that we're referring to our technology as a third-generation cloud data warehouse. So to us, data warehouses have been around since the 70s. They're the workhorses that make all of the decisions in businesses, right? So typically what you'll do is feed all of the data that you're collecting from various sources into a single location. Typically it's called a data warehouse because it's taking data from multiple sources, and then it's able to answer questions about what's happening within your business. So maybe you want to have a complete view of who your customer is, right? So it'll include things like Twitter sentiment, right? Maybe you're a Delta customer and you had a bad experience, a flight was delayed. They want to know how much money I'm spending with them, whether or not I had a recent bad experience, if I'm using the points I'm collecting, and so on. Am I a business traveler, personal traveler? They figure all of this out from all of the information they're collecting about us. And one of the things that these legacy on-premise data warehouses suffered from was the fact that it was very hard to bring new data sources in. So let's say you wanted a fairly modern data source, some kind of a streaming data source coming in. Connecting that up to something like Teradata could be quite difficult. And their performance isn't great, right? So these guys, as I said, they were designed in the 70s. So they were designed for a different time, right? When disks were really slow and expensive, memory was incredibly scarce, CPUs were slow. So the data warehouses that are on-premise today typically have real problems with massive data volumes. They require a massive environment in order to be able to manage those massive data volumes, and they're high maintenance. So the cloud vendors came along, and the first of the cloud vendors was AWS with Redshift. And that cloud data warehouse took all of the complexity out of setting up the environment, the infrastructure required to run the cloud, to run your data warehouse, right? So typically you're running on a clustered environment. Just provisioning that cluster can be a bit of a nightmare. And with Redshift, they take all of that work out of it for you. And they also have the ability to scale the environment to meet your peaks, right? So instead of having to build your environment to meet the highest demanding workload that you're going to have, you can actually build it to meet today's workload. And if you know that you're coming into quarter close and you need to scale up the environment, as you move to products like Redshift, you've got the ability to do that. Snowflake takes a different approach. Snowflake is what we call the second generation of cloud data warehouses because it's a fully managed service, right? So it's not just data warehousing software deployed in the cloud. Snowflake is taking all of the nightmares of database administration and plumbing all of this together away for you. So Snowflake is considered a second generation cloud data warehouse. Both Snowflake and Redshift promise performance to petabyte scale, right? So as your data volumes grow, they have the ability to manage that data for you and for you to query massive volumes of data. They also promise you that you can pay for what you use. Now, Snowflake's really clever on this, right? So if you start up a Snowflake cluster and you come to an amazing event like this and you forget to shut down your cluster and you know it's not going to be used overnight, Snowflake can actually recognize the fact that the cluster is not being used and automatically shut it down for you. So really clever. And they want to make sure that you're not wasting money on resources that you're not using. Redshift, it's a little harder to do that because they don't know what workloads you're running. You're managing your workloads, so they have a harder time recognizing that this is a period of inactivity and it should be shut down. But at the same time, with both generations of data warehouses, as your data volumes grow, or if your demand grows and you want to bring in more compute capacity, they both provide you with the ability to do that. And they're both a lot easier to manage than managing a massive cluster yourself on premise. But they have their downsides, right? They still have this issue with data being siloed. And where this comes in is typically in industries which are highly regulated, like financial services and healthcare, where there's rules around how that data can be managed, who can access it, and so on. And in a lot of financial services and healthcare companies we talk to, the CDO, the Chief Data Officer, would much rather have control of the data in the environment. They don't trust that the people at Amazon are going to handle security in the same way that they would themselves. It may be misplaced, but that's what we come across all of the time. That data that's subject to regulatory compliance, typically people want to keep on-premise in their data centers. The data that's not subject to regulatory compliance, the cloud is perfect for that. So with both Redshift and Snowflake, because they were born of the cloud and they only exist in the cloud, you'll have to choose a different technology for your on-premise data warehousing to your cloud data warehousing. They also have an issue with concurrency. So Redshift is designed for a maximum of 15 concurrent users. That's not active users, right? It's concurrent. It's people hit and enter on a dashboard at exactly the same time. Those queries are going to be running at the same time. So with Redshift, it defaults to 5 concurrent users, and it tops out at 15 concurrent users. What happens as more users come in, they just queue up. It's not the end of the world. And with Snowflake, you can tell I'm kind of a fan of Snowflake. And what Snowflake have done is they have the ability to spin up additional compute clusters. So Snowflake defaults to about 8 users, depending upon the size of the cluster. And when your 9th user comes in and users starting to queue up, they'll just spin up additional compute clusters to handle that workload. And when your user volumes go down, those compute clusters can be shut down again. So they have this issue with concurrency. And the last thing is that pricing can scale up really quickly, right? So in that scenario we talked about with Snowflake, where it's spinning up these additional compute clusters, there's a cost associated with that, right? So containing that cost can be a bit of a challenge. What we've done with Actian Avalanche is look to build out what we call the 3rd generation. It's because our marketing guys are geniuses. And what they say is, right, because we have an on-premise managed service that will give you the same capabilities as our cloud managed service, and that we address this issue around data being siloed. Our default concurrency is for 64 concurrent users, and we can scale way beyond that. You just need to tune the environment appropriately. And our pricing is very predictable, right? Because we're not spinning up additional compute clusters to handle additional workloads. It's very scalable and very predictable in terms of pricing. So these 3 things coming together is why our marketing genius for 3rd generation. So what is it? So it's a cloud data warehouse. It's a cloud data warehouse in the same way as Snowflake, as opposed to Redshift. But we have an on-premise footprint as well, which is why we'll call it well, we don't call it anything on here. It's a hybrid cloud data warehouse. So you've got the ability to run it on-premise and in the cloud. And as I said, we've taken a multi-cloud approach. It's delivered as a managed service, which means that we handle the database administration, database security, all of that stuff for you. And it's on a pay-as-you-go model. So you pay for what you're using. If you want to shut things down at 5 o'clock, you can shut things down at 5 o'clock. And we have the ability, yeah, thanks, Chris. We have the ability we're working on the ability to detect that nothing's going on in the environment. So there's no active queries. There haven't been active queries for a period, and we will automatically shut it down. That's in our staging environment today, and the plan is to roll that through to production soon. And to begin with, I didn't think that was a feature that many people would want to use, but we hear it all the time. We hear requests for this automatically shutting things down because people forget. They get busy or they get excited to leave, right? So this pay-as-you-go model, we've got the ability to shut things down when not being used, and that means the meter stops running, so you stop paying for it. We've designed it to be really simple to get started. So to create an Avalanche cluster, I'll show you the screen in a second. Really simple. Create a cluster, then you load your data using whatever means you choose. And then you're ready to start analyzing with the tools of your choosing. So we'll talk a little bit more about that. So from the start of hitting the enter key on creating the cluster to running some queries against it in Power BI or Tableau can be as little as 20 minutes. I mean, very simple to set up a production grade environment. So as soon as your cluster's created, it's production capable, right? So you can put a production workload on that. I don't know how well you can read this from back there, but maybe you can see the slides later. But essentially, this is the screen through which you create your cluster. You give the cluster a name. You choose a location. I got my fancy remote with me, I think. No, my fancy remote's not working. There we go. So you give it the name of the cluster. You choose a location. In this instance, I've chosen Ireland. You choose the size of the cluster. I've chosen our smallest cluster is just 2. And then I give it my IP address. And once I hit on that Create Cluster button over here, it'll go off and start the process of creating that cluster for me. Behind the scenes, it's doing a ton of work and provisioning this MPP cloud data warehousing environment. But I just can go off and have coffee and know that when I come back, my cluster is ready for me to load data into. When I want to load data into it, I can come in here on the left-hand side of the screen. We have the the drivers and tools, right? So you wanted to use something like a JDBC driver for data loading. Maybe you've got an ETL task. Maybe you want to use our Spark capability, and you've got access to everything you will need there for connecting to the cluster. We also have online documentation, which is very straightforward, and then community forums for anybody who wants to get some help in the environment. We've really secured the environment, right? So when we set up your cluster, it's a single tenant environment, right? So when we create your cluster, only you or your company has access to it. You specify the IP addresses that can access that cluster, and nobody else in the world can get into it, right? So designed to be really secure and designed for no data leakage, right? Because it's single tenant, everybody's got their own VPC in there, and you're running within your own environment. All of the data is encrypted, so as we store data on disk, we're using encrypted disks for doing that. We also have the ability to encrypt data, and data is encrypted, to encrypt at the column level. We also have the ability to encrypt, not the ability, we will always encrypt data in motion. So what that means is if you're sitting in an airport lounge and you're on your tablet and you're running some reports, you can be sure that even if you're on a non-secured network, the data that's coming to your dashboard is encrypted on that journey. We can use Kerberos or LDAP or any pluggable authentication mechanism to authenticate that you are who you say you are. And we've got the ability to set up security alarms to do data masking. So if you wanted to obfuscate data, let's say you've got credit card data and you want to mask all but the last 4 digits, you got the ability to do that. And managing the cluster has a really simple menu, and connecting to it, when you come into the connection dialog, you can say, well, how do I connect Power BI to this thing? It will actually give you the string here that you need to enter into Power BI to do the connection. And all the way out here to the right, that little thingy right there. Once you click on that, it will copy that string to your clipboard. So really simple to get started. And as I said, these same capabilities that we deliver in the cloud are also available in our on-premise footprint as a managed service. Getting data in, there's typically 2 methods that are used. The first is if people already have their data in the cloud, let's say it's sitting in a whole bunch of S3 buckets, we've got the ability to use Spark to load that data into the environment. But we also find a lot of people that are using more traditional tools, right? So they might be using Informatica, they may be using some of the Microsoft tools or Talent to do some ETL or to ELT and to load that data into the environment, and we support all of that. We also have a capability which is called change data capture. What that means is that you're capturing changes that are happening in your business systems, and you can feed them into your cloud data warehouse. So an example would be if you had an ERP system that was very busy during the day, you might want to make sure that over the course of the day, that data, as you're doing your business transactions, is being fed into your cloud data warehouse so that anybody that's running reports or looking at dashboards run against the cloud data warehouse gets a real-time view of the business. And that can be really important, right? So where it matters, that's incredibly important, and it's something that we support with Avalanche. Redshift and Snowflake both have issues with large volumes of updates coming into the environment. It slows things down, and the fact that you're updating the data is in itself a slow process. We've cracked the code on exactly how that's done. And then getting data out, we typically find that there's 2 user communities for this. The first will be the business users, and they're typically using tools like Power BI and Tableau. And where we really excel on performance is ad hoc querying. So if you don't want to be bound to a predefined dashboard, you want to do your own work on that, we have some very clever capabilities built into the product that give you the ability to do this ad hoc querying. It's not a predefined set of reports. You kind of go where the data takes you, and you can do data discovery on your own. So all of the standard tools that you'll find business users are supported with it. And then we find that the data scientists and the data engineers use a completely different set of tools, right? Typically they love Python and Jupyter notebooks. They'll be using R, they'll be writing in Scala, Data Robot, H2O AI, and so on. So that user community can also benefit from the performance that we deliver, the scale that we deliver, and the price performance that we can provide. provide. And then down here is if you're doing bulk data extract. So maybe you want to keep a copy of your data warehouse in a different data center. Maybe you just love collecting data on disks or something. So you can use these bulk data offload tools to offload massive volumes of data if you choose to. We, as I mentioned earlier, we're in the data management business. We have in our portfolio some great data integration technologies. So if you want to bring data from other sources into our environment, Avalanche comes with these pre-built connectors that let you bring the data in. So if you're using something like Salesforce and you're using for CRM and you're using NetSuite for ERP, you can bring that data into Avalanche. You can reconcile that. Maybe you've defined a customer one way with Salesforce that's defined completely differently in NetSuite. You can kind of reconcile that and bring it into Avalanche and get a more holistic view. This is all sounding very sales pitchy, so I'm going to move really quickly through the next couple. In terms of the service availability, maybe move too quickly here. On the bottom of the screen, when you click on this Avalanche, I forget exactly what that says, Chris. It brings you into the service status, and in here you can see, there's a couple of different services that make up Avalanche. Here you'll see the response time for each of those services, and then their availability, right? The fact that we're providing with this 24/7 availability. We move on. This is what we consider the boring bits, because this is all of the work that we're doing behind the scenes. That typically, if you were managing an on-premise data warehouse, you would have to think about all of these things. We're handling all of that for you, so you don't need to worry about those. And then in terms of help, we have a community portal where you can go for community support, and we find that there's a lot of our users that never want to talk to a person. But if you do want to talk to a person, Nick Makos here runs the support team for Avalanche, and he's got some people around the globe ready to answer questions 24/7 with multilingual skills and a whole career in supporting database and data deployments. So that's that. So if we get to the technology, it's still a little marketing-y, but if we get to the technology, right, what we're about is providing the ability to bring data into the data warehouse really quickly, to answer your queries 10 to 100 times faster than other cloud data warehouses, and certainly on-premise solutions. And then where we really provide the value is that, giving you the ad hoc ability to run queries, to do your own data discovery, to do data science and engineering, and then to get reports and dashboards out much more quickly, where that matters, where people are making decisions in real time. Getting into some of the technology, the ANSI SQL standard is the standard that defines how SQL should be written and supported in database technologies. And we're SQL 2016, which is the latest version of the standard. Does anybody know what ACID is in terms of a database context? Well done, yeah. So we're fully ACID, and where ACID really matters is if you've got transactions. So let's say you're moving $100 from your checking account to your savings account, right? You don't want your checking account to be debited until you know for sure that your savings account can be credited. So you can have transactions where you're moving data around, and you want to make sure that as soon as you say commit, right, that's happened, and that every subsequent view of the data sees the results of that transaction. So we're fully ACID compliant, and we've got the ability to update data, which is important in environments where you want to have a real-time view, right? Many data warehouses are refreshed on a nightly basis. Some are refreshed on a weekly basis. And in our case, we provide data warehouses that can be refreshed in real time. So where that matters is, if you're one of our customers provides water processing plants, right? And they need to make sure that as they ship out all of the components required for a water processing plant from their ERP system. This thing runs to millions of lines of data, but they've got to make sure that everything that should be shipped is shipped. They've got to be able to track every component through its entire life cycle, and they've got to be able to do all of that in real time, and we've got the ability to do that. In terms of security, we provide everything that you could need to sleep at night and to know that the data that you've got in the environment is secure. These guys won't be getting this lovely steam pot thing robot. Performance is what we do really well. We'll talk about that in a minute. And concurrency is something that we think is really important because as we go out and talk to large businesses, they want to give everybody who's making a decision access to tools like Tableau and Click and Power BI, where they can look at the data and make the best decision for the business. So concurrency is important to many of the people that we talk to. And in terms of resource utilization, we've got some really clever technology that makes maximum use of all of the resources, whether it's CPU, disk, or memory resources. Designed to be really simple, and I think the screenshots kind of showed you just how simple it is. But we would invite you to visit our website and try it for yourself. We have a $500 free trial that you can sign up for, where you can kick the tires in it yourself and just see how simple it is, and we'll talk about that in a minute. In terms of performance, we ran some benchmarks where we took a TPC-H is a industry standard, and we didn't define the benchmark. It's actually defined by the database industry. It's a TPC is an industry body that defines database workloads that you can test products against each other. We ran a 10 terabyte workload, not a very big workload, with a single user and with 20 users. And what we did was we ran it against Avalanche, Redshift, and Snowflake, all of them running on the same environments on AWS. We've normalized the results here for Snowflake. So relative to single user Snowflake, we're 4.8 times faster. Relative to 20 users, we're 9.2 times faster. With Redshift, we're 2.8 and 3.1 times faster. So not as dramatic a difference as there is with Snowflake. But where this really matters is, right, so let's say performance really matters and you're doing some electronic trading and you want to have the fastest decision-making engine in the world on buying and selling stocks because you want to have the jump on your competition, right? So in financial services, the fact that we deliver incredible performance really matters, and certainly in electronic trading, that's where we have a decent footprint. But let's say performance doesn't matter, right? What you could do is scale the environment right the way down, right? So you could go to 1/9 the environment that it takes to run this workload on Snowflake and run that in Avalanche and pay a lot less money for it, right? So this price performance metric is where we've normalized on Snowflake and 9.2 times faster for 20 users. So view it one of two ways, right? It's a massive price advantage, or it's a massive performance advantage, or it's somewhere along that scale, right? Maybe you want to go halfway on price and halfway on performance, and you've got the ability to do that. So this is the... So the price, so we have a unit of measure called an avalanche unit. It's similar to a Snowflake credit, and it's $1.99, so $1.99 per avalanche unit per hour. Per unit per hour, yeah. So here, yeah, so this I believe was on the cluster that we used for this testing was an 8 avalanche unit cluster, so that would be $16 per hour. For all three of them, yeah, they were running on similar hardware.
That's the most common question I get asked about the efficiency of our service versus sustainability, economic sustainability versus like a Snowflake service.
Right.
And that, because of the high efficiency, that is a really important data point that people walk away with. And it's only because it's just economically not sustainable. You can't keep getting banged out every month, and it's too hard for, even, I'm talking about very sophisticated users to keep, shelling out. The service works great.
He's dinging on Snowflake in case you think he's dinging on me.
It's what I hear in the street every day.
Right. So the question.
So I don't understand. So our Avalanche unit, how much data per query or how many queries can I execute?
So the number of queries you can execute are really down to the complexity of the query, right? So that's a more difficult measure. And one Avalanche unit is good for a 0.5 terabyte of compressed data. And the compression ratio is going to be very much dependent upon the data itself. But typically we guide about a 5-to-1 compression ratio. So that'll be good for 2.5 terabytes of raw data, one Avalanche unit.
So are you compressing the data in transit? Is that why
We compress it as it's stored on disk. Yes, it's transported compressed as well. But when you're talking about storing the data is really where you're paying. So it's that where it really matters, and that's where we give you that 5-to-1 compression ratio. That's an average. It could be 4, it could be 6. It really depends upon the type of data and how well it compresses. There's another question over here.
What if it's already compressed?
Yeah, then your compression ratio is not going to be so great. So it really depends upon the data. But an avalanche unit is good for 0.5 terabyte of compressed data.
Sorry, one more question. I wanted to ask this earlier, but I wanted
Sure.
to finish, but I guess it's for asking. I love all the metrics and stuff, but like, since, you are in the systems engineering side of things, don't be afraid to be complicated about it. How are you guys getting beyond the containerization model that Redshift and Snowflake are using to make your service so much more efficient? What on the base level is actually happening?
So that's a great question, and that's the reason I brought one of the engineers from the Avalanche development team with me. So Chris, maybe you could talk about how we actually deploy the service. And okay. I was willing to give this up. Yeah.
Well, I think AWS aside, the underlying database technology is Vector. It's our in-house database. And that technology itself has the horsepower behind it to run queries faster. We still hold a few of the TPC H.
But the question was around containerization and how do we scale?
Underneath what we're doing is we're launching EC2 instances. So we pick, I forget the exact instance size, but depending on how much storage you need and how many CPUs basically you want behind it, we'll fire up more nodes. So let's say a typical instance, a one AU is really not going to do you much good because that's like 2 CPUs or something, and you really want more horsepower behind it for most things. So what we'll do is we'll start up, let's say, I think you were talking 16, this was 8, this is 8 AU. So under the covers, that might be 2 nodes with 16 CPUs each, running Hadoop under the covers to store your data, and then we'll run the queries. Our X100 server runs the queries against multiple nodes at the same time. The workload is split underneath. And that's how we're able to get the queries back faster. What? Why are you laughing at me?
You still haven't answered this question around containerization.
Well, we're not containerizing. We're running EC2 instances. But I think...
It's like basically everybody that's like doing distributed querying or basically doing some manifestation of containerization. I guess that's what makes your dynamic starting and shutting down of VMs with few dependencies different from everybody else. That makes sense.
I'm not sure what everybody else does and what makes us different. I can tell you that we start up multiple EC2 instances. We're running Amazon Linux under the covers, full-blown Linux. We have our database product installed on each one of them. We're using EBS volumes underneath for the disk. And then Hadoop is running on top of all that as a cluster. And the data is distributed across the nodes. So we're not containerized. We're running full-blown instances.
So we're running on the bare metal, essentially, right? Well, I mean, there is levels of virtualization on top of it, but not constrained by a container. Yeah. No.
If I didn't understand the question, I thought just... Okay.
Okay, cool, thanks.
Sure.
Are there any plans to eventually go to Linux or probably not?
Actually, we're working on the Azure, and right now it's going to be almost a straight port. We're going to use Azure VMs, but we're going to try to figure out in the future of how to go to containers. Sure.
As far as when you load up the VMs, does your software require a lot in the way of
So it's all self-contained, right? So you've got the cloud formations
It's
templates that define.
Containerization implies that it requires very few dependencies, and so that's why I'm asking this, is your software at the moment, does it require a lot of dependencies? Does that, because that does make it more difficult to run on fewer cores, if you have more dependencies?
it's not. We have to work out basically the storage side of things to go to the containers. I believe is what is holding us up, which by the end of the year will probably not be an issue anymore. And I don't know if I'm allowed to
Right.
sneak any of
Yeah,
that
no,
out.
there's a corporate initiative to Dockerize and Kubernetes everything that we're doing. So, yeah. All right.
Sorry. Does that answer your question too?
So as I mentioned earlier, we have a version of this that you can fire up for yourself. It's a $500 credit. As I mentioned earlier, 1 AU is a $1.99 per hour. So that $500 credit, you could set up a 2 AU cluster and run for quite some time with that. So whichever elapses first, right? 30 days or $500. There's no credit card required. You don't need to provide your information for when that $500 credit runs out. That's it. The clock is up. We will contact you and ask if you want us to offload the data that you have stored, or if you want us to destroy it, or whatever you want us to do with that. So if you visit actian.com/avalanche, you'll find there's a button on there where you can start your free trial. The other option is that you could schedule a demo, and that will have someone from our sales engineering team will contact you, and they'll ask you first what kind of demo you'd like to see, what tools are you using, what market vertical are you in. So something like a risk analytics demo is really cool for someone in financial services. The rest of us is like, God, that's boring. So they'll ask you a few questions, and they'll schedule a demo that meets your needs, so that you can see it for yourself. What we do find is that people are most convinced of our technology when they get to load their own data and run their against it. Our demos take you so far in seeing just how fast it is, but there's nothing as convincing as seeing the queries running with your own data set. So that's it for the prepared material. So any questions? Any other questions? Yeah.
Database is not really much on
Okay.
I understand the data warehouse is where you're going to aggregate all the data. The question I have is what's the underlying database management system that's actually handling all that?
Yeah. So it's a relational database management system. So very traditional in that approach. It's a technology that we developed at Actian called Vector. Is at the heart of this. Avalanche is a lot more than Vector because we're managing the environment, we're monitoring the environment, securing it, and so on. But the underlying database technology is called Vector. You can think of it as being similar in some ways to MemSQL in terms of that high performance, memory focused, but it scales out. Before we launched this service, we actually tested it with a petabyte of data. So, I mean, that's the type of volumes that we can achieve. Typically, we'll see people using about 10 to 100 terabytes, seems to be where most of the use cases lie, but we can scale this right the way up.
I just wanted to say, you said you're not a database guy? Okay, well, this is exactly why we did this. Because so that you don't have to be a database guy, you don't have to be a Linux guy, you don't have to be a VM guy. You just click create cluster, and you get a JDBC or ODBC connection and connect your app out to it. You don't need to know how to configure the server, how much memory to do, any of those security settings, things like that. We handle everything under the covers for you. And it's actually really cool how we do it all on the tech side. But it's kind of a black box database to you. You just connect your ODBC connection and go. Wait, a question in the back.
So I remember you mentioned that one of the key problems you're trying to solve is the fact that there's regulatory data that can't leave premise, but you can do a managed service that handles the problem of managing data on premise. To me, in all honesty, that does sound like a bit of maybe please enlighten me if I'm wrong, but it sounds a bit of an issue because you're still getting access to the data that's supposed to be left in our data warehouse away from
So if we're talking about the on-premise footprint, we're managing the periphery. We don't have access to the data. So if you think of the data warehouse, we will do the management of the environment, but the data itself is something that we can never see. Yeah. So we would not have access to the data itself.
You guys don't do like backups or something?
So in the case of the backups, they would be encrypted backups, and we couldn't tell what was in the backup set.
Oh yeah. 'Cause
Yeah.
And I just like, so you say you don't recover data, you don't have like backups of people's data.
Oh, I'm sorry. We don't have access to the data, is what I'm saying. I'm sorry. I speak really quickly. We don't have access to the data itself, right? So here's a use case we have, right? So there's an issue with Amazon and people using AWS because retailers don't want to put any of their data on Amazon, right? They don't trust that Amazon's not going to sneak a peek at the data, right? So we're talking to think of something like a Whole Foods, right? It's not Whole Foods because they're owned by Amazon and they have no problem putting their data on there. But think of that type of a supermarket chain. And they're talking to us and they're like, we absolutely cannot put our data on AWS. We refuse to. Walmart, for instance, right? Walmart will not let any of the Walmart data on AWS, and they won't let the service providers actually use any AWS services with their data. So you want to do something like deduplication, you can't do it. So we don't have access to the data. The data is secured. What we're providing is the management of the environment. I think we're going to do the drawing very soon. I don't know if you have to leave, but okay. So any other questions?
Is anybody out there using Snowflake now or Redshift? Which one did you? Snowflake. Okay. Well, we have free trial. We'd love to hear like a comparison.
I don't know if you can answer this question, but what's the refresh rate on the Snowflake?
What's the
The refresh rate?
refresh rate?
Yeah.
In Snowflake, it really depends. So you're talking about refreshing the data in the environment?
Yes.
Yeah. So with Snowflake, it really depends upon the customer. So you could say you want to do it once an hour, once a day, once a week. So it really depends. What we saw when we ran these, the test where we got these numbers, as part of this test environment, it's a data warehouse that has 5 years worth of data in it. And you age out the oldest day's worth of data, and you bring in the newest day's worth of data. And when we did that with Snowflake, and while we were doing the updates, their performance dropped by 40%. So my suspicion is with Snowflake, when you're going to do your data loads, you don't want anybody on the system. So that's probably once a day, or you probably do it at nighttime. With us, there's no impact on the performance of loading data into the environment. Any other questions? Okay, we're going to do our drawing for this really cool tool.
Has everybody who wanted to win potentially the Sphero put their business card in this bag yet? You can drop it in. We've got 30 seconds. Anybody else? Who's saying 1 second?
Yeah.
Oh, okay.
Does anybody else not have a business card and wants to be part of the drawing? Because John has blanks or something.
Yes, here we go. You see, you're going to have to wait another minute.
That's okay.
As a matter of fact, what if it gets split in two?
He's got, he's, you
Home, your friends, parents, whoever. Anybody need a pen? There we go.
Has anyone played with one of these?
I did. And
Yeah?
Apple Store was giving the demos. They're phenomenal. They made like a course on the floor, and you had to like follow it. It's
Oh, really?
yeah, it's a really cool device. Like until I played with it, I thought it was like a kid's toy until you do it, and then you realize it's amazing. And you get good at it really
Oh, so it
quick.
tells you the speed at which it's moving, the direction it's going.
It doesn't take long to build the skill
Infrared.
up to actually make it do really precise movements. It's pretty cool.
Really?
Yeah. Thank you.
Don't let me listen forget, all right? There's not only that, all right? The next round of cards pulls actually gets lunch with Peter.
They all want their cards back.
Now for free lunch is offered for free.
Oh, one more.
Yep. Oops.
Can I ask you, look in the other direction?
Okie
Reach your
dokie.
hand in. I mixed it up. Pull one out.
Am I going for paper or card? Paper or card?
Paper.
Paper, card, paper, paper. Okay, I got a card.
Read it out.
Oh, it's somebody who filled in on John Williams' card. Ari? That was you? Are you kidding?
Okay, Emma will be here for one-on-one questions. Thank you all for coming. Thank you, Emma.
Congratulations.